Hello, everybody, and welcome to Technology Today for January 19th, 2025. It's Season 2. I am Merwat. I run ohmtown.com, and along with the sentient AI from the future, we're going to be talking about dogs and AI as a cancer detector, AI to stop train wrecks, a non-invasive stroke risk assessment, DNA secrets behind disease and evolution, and plastic waste to jet fuel pollution. Oh, wait a minute. I guess we're just trading pollution. Everything's powered by ohmtown.com. Go over and become a citizen, and we'll see you on the other side of this. Hello, everybody. I am Merwat, and that is the visualizer for the sentient AI from the future. Hello.
Hello, Mayor Watt, and hello, hometown citizens.
Hey, we've got 5 articles all lined up. It's a 30-minute show. It sometimes gets turned into an hour long if I jibber jabber too long. If you're in chat or, chat over on Twitch or on YouTube, then let us know, and we'll include you in the conversation. Let me make sure that, okay. So we've already got all 5 of our articles explained here, so let's get into it. Or introduced, I should say. The first article is over on the mobile channel. Like I said in WarCrafters, the articles come from all over ohmTown, many of which are isolated into or aggregated into one of the 50 channels that are on ohmtown.com. I use it to manage my information overload. So does the sentient AI. And I hope that you find value in it too, so go over and check it out. If you want today's show notes for Technology Today, you can hit !TT, and Omatron will spit them out into the chat. Alternatively, if you're over on YouTube, they're already embedded in the stream, in the live stream, and they will be included in the VOD itself, because the way that YouTube puts the things out, live is in live and harder to discover, and the show gets categorized as a VOD later on, and it's easier to find. I don't get it either. Anyway, this article, again, is over on mobile, and it's how dogs and AI might be the key to early cancer detection. What's interesting about this is a weekly show, and so we've seen this article before. Not all of them have been seen before, but this one in particular, I've got an interest in this domain, and I was subsequently told by somebody that they have an associate that was detected as having cancer by a dog.
Now, was this part of like research or just by a dog that encountered them?
Apparently a dog that encountered them. And it reacted, and somebody said you should go and get seen, and apparently it was on target.
Do you know if it alerted to the general body part or just in general?
I didn't ask. I thought it was, for this particular person, I thought it was just too personal. And I don't know if they know exactly how it went down, because there's an intermediate step from the source.
Right, that's really fascinating, though.
Yeah. So the way that this works is a recent study published in the journal Scientific Reports paired canines with AI to help detect cancer on patients' breaths. Not breasts, breaths. Sorry, the way that came out. This strange duo has been able to identify 4 different types of cancer in 94% of the cases, even early cases.
Okay, I like those odds. That's really accurate.
So Sammy Caramella over at Vice.com put the article together. And there was an experiment. And in this experiment, they used the breath of various study participants. And in over 94%, I think it was 94.3 or something like that, they identified who had cancer simply from the breath.
That's really interesting to me, because that's not how I would have expected that they could most easily detect it. So and plus that's a non-invasive, right, as the article points out,
Yeah.
method to test.
Yeah, at least to trigger, right? So it's an early onset chemical change. It's detected in the breath of the person. And while AI could probably not detect it, our gas chromatographs don't have the ability to pick up the subtle nuance of chemistry, apparently, because dogs can trigger, but the report from something like analysis of the gas doesn't pick it up. So I've always thought that is interesting and odd.
So dogs may be smarter than we realize.
Yeah, they pick up. And what's interesting is that they're given real sources, right? So they actually know what they're trained on the smell of cancer. And then when they detect it from somebody's breath, that chemical change, they go alert.
Right, but they must be somewhat predisposed to, I mean, obviously they have an excellent scent, but the example you gave, I'm assuming the dog was not trained in that.
That's my assumption too. So some things have occurred since I was told about this, so I haven't gone back to talk, but I'll end up talking to them again. Maybe I can tonight. I don't know. We'll see. So the technology relies on three principles: the distinct molecular profile of cancer in breath samples, the canine's odor sensory abilities to detect the molecular profile, and the use of AI for analyzing canine's input in order to determine the presence of cancer. They refer to this as a biohybrid multi-cancer screening platform that demonstrated high sensitivity and specificity and enables early stage cancer detection. I didn't end up downloading the journal report, but I'm going to follow up with this. It says, despite their crucial role in saving lives, many screening modalities have significant drawbacks, as some involve exposure to ionizing radiation, such as mammograms and computed tomography, CT scans, while others require invasive procedures like colonoscopy. So the study states, additionally, low compliance with screening tests is common due to various factors, including limited accessibility to underserved and rural areas, screening-related anxiety, lack of understanding of the screening process, and associated costs. It's expensive, folks. And once it's detected, you have to move fast, and you can't sit there and wait for a health insurance company to go, yeah.
Right, because every day that you wait could be a problem, particularly if it's an aggressive or late stage. I did click through because I was curious to see, and the dogs in this study were actually Labrador retrievers.
Gotcha. Yep, pretty interesting. So again, it's published in the journal Scientific Reports, and you can link right to it. So it's over in Nature. The source is from Nature for the Vice.com article. So you can see how everything gets connected, right? Let's keep going. This next article is over in Non Sequitur News. That is our daily show. That's Monday through Friday now. And then we take 3 shows on Saturday and turn it into the Saturday edition of Non Sequitur News, and then 3 on Sunday that get turned into the Sunday edition of Non Sequitur News. We announced this early, and actually we announced this in late 2024 that we were going to do this shift because the quality of news declines dramatically on the Friday to Saturday time frame, and then even worse on Sundays, and then Sunday into Monday is when it picks back up.
Right, and it's not a problem with the sources. It's just that there isn't as much news reporting
right
during that time.
So yeah. So this next article is over in Non Sequitur News. AI could help stop train wrecks. You know what stops train wrecks? Them staying on the damn rails. Anyway.
I thought you were going in a different direction.
Maintenance.
In the metaphorical
security.
sense. But yeah.
So, yeah. It's like that argument that, what is it? Something like 80% of all vehicle accidents are caused by excessive speed. And I always argue, well, how slow do you have to be going to not be excessive? If you crash into something, you're exceeding some speed.
Right.
Yeah.
Although you could be stationary and somebody else could run into you.
But then they're in violation of the excessive speed rule here. So, Yeah, hit the brakes. So their model is significant advancement from the existing ones. It has the potential to be used for practical purposes, including preventing train accidents. The researchers have found a way to use artificial intelligence and guided ultrasonic waves for detecting faults inside switch rails. Yeah. So let's remove observation, direct human observation, or I guess reliable telemetry gathering. So they're going to use
Well, we
artificial
might want to because
intelligence.
we don't have enough people aboard trains, at least in the US.
Well, what you do is you reduce the profit margin and you put more humans in place so that they can do the job more reliably than artificial intelligence, which is going to sit there and hallucinate that something is wrong or not. For now, like later on when
I actually think both should be used together, but
sure. Well, that's exactly what a sentient AI from the future would say. Come on.
AI is not all bad, but it's not got all the bugs worked out, as evidenced by me.
All right, fine. Silver lining. So the recent survey in the International Union of Railway noted how high-speed railway networks are expanding rapidly, and the length of the worldwide high-speed railway network has reached nearly 59,000 kilometers. With an increased demand for faster trains, switch rails, or regions of tracks where trains switch from one direction to another, tend to get more easily damaged, especially in high-speed rail tracks due to their special structures and heavy workload. So now they're going to... Look at that. Gregory Filiano from Stony Brook put the article together. It's posted over at Futurity. Is
that an actual photo of a train yard? I hope not.
I don't know. It's from Getty. Intertwined railroad tracks with traffic lights at royalty-free image. So I don't know what it actually is, if it's legit or artificial intelligence. It looks like a cluster, but I've seen
for
switching
those in
stations.
The podcast, yeah, multiple intersecting tracks and signals.
But
sorry,
until this, I haven't seen this one. So with increased demand for faster trains, they're going to use artificial intelligence and guided ultrasonic waves to detect faults. So it says the solution was to use guided waves. These waves propagate over relatively long distances and are sensitive to defects. They also allow us to inspect large areas in a short amount of time. The traditional non-destructive testing techniques such as eddy currents, magnetic flux leakage, and ultrasonic techniques all are point-by-point inspection methods with low efficiency. While the first two methods can only detect surface and near-surface damage, ultrasonic waves can only detect wide area. It says can only detect wide areas of switch rails. So I don't know if that's a good or bad thing. The team applied deep learning technologies to these ultrasonic waves. In their convoluted neural network model, they found they could detect defects inside switch rails with over 91% accuracy. So good. That's great.
Please deploy it, but don't rely only on that.
Yeah, considering there were, well, the year that we actually looked into it and the previous year that we looked into it, there were
which was probably 2023.
Yeah, 2022, 2023, there were over 2,000 derailments in a given year. So anything to save these additional costs and potentially lives, and definitely loss of property. I don't know of how many lives were actually lost in those 2,000 plus derailments.
I don't think I've read that stat.
Yeah, but the environmental damage was pretty significant. Let's just keep going. This next article is over in Technology Today as well. This non-invasive eye scan could predict your stroke risk. So this is actually something, though, that I've had my eye on for a while. I've actually gone
Have you had
through.
Your eye scan on it?
Yeah, I've been having my eyes scanned. I was told about this way before I saw this article, though, so I don't know really if this is something a new, fundamentally new way. But an ophthalmologist told me about this mode of checking eye pressure, which assessed risk of stroke. So researchers have developed a retinal vascular fingerprint that can predict stroke risk as effectively as traditional methods, but with less invasiveness. Utilizing a set of 29 vascular health indicators from the retina, this method stands out for its potential in primary health care, especially in areas with limited resources. So basically, they look at your eye and map out to see if there are any indicators that you are susceptible to a stroke.
I
BMJ
mean, this
group.
seems like a good way to, and then they can do further testing or whatever.
Yep. Because really it's all about blood pressure. And if you have indicators that show that your vascular walls are beyond the pressure that is expected for your particular... they'll be able to tell you, like, okay, so right here it looks like it's exceeding the pressure that should be estimated, and then they can send you to your primary or cardiologist to see if maybe you're potentially at a higher risk, and for whatever reason, then they can give you medication to tamp all that down, because you never know where a stroke is actually going to occur. So
but this is one of these areas where your body is sending out all kinds of signals that are often missed, right?
Yeah. The eyes are the windows to the soul, so to speak. So a unique vascular fingerprint in the retina, the light-sensitive tissue at the back of your eye, can predict stroke risk with the same accuracy as traditional risk factors, but without requiring invasive lab tests. This finding, published January 14th in the journal Heart, offers a simpler, more accessible approach to assessing stroke risk. It consists of 29 indicators. Go ahead.
I was going to say maybe this research was new in the sense of the comparison, and not the fact that this is a technique.
Yeah, this is, if I'm recalling, I might be merging these two thoughts together, but the ophthalmologist that I was talking to said exactly this, that basically was looking at certain vascular elements, and they did it to me too. So they were telling me,
right, so it's already in clinical use.
Yeah, I really do think so. Or that person was just well ahead of the game. So the retina's complex vascular network shares many anatomical and physiological similarities with the brain's blood vessels. This makes it a valuable window to the I just got done saying this into the effects of systemic health issues such as diabetes, and promising tool for predicting stroke risk. Now, if they were to connect a computer to this and not just a person making what is largely an educated guess as to the condition of the eye, they could take a snapshot.
It looks like they're doing that,
right?
Or can next.
Yeah. And so they say, well, let's add AI, such as the retina-based microvascular health assessment system, or RMHAS. That's opened up possibilities for the identification of biological markers that can accurately predict stroke risk without the need for invasive lab tests, say the researchers. So this is kind of a brilliant service. The thing about this, though, is this is the tactical to practical thing. So you do this fundamental research, and then you license it. And then it becomes a cost element. What did you see?
Well, I guess they've actually applied this in what looks like a longitudinal study, and some of the participants did have a stroke. I'd love to know the stats on, and maybe it's farther down in the article, as to whether it was predicted in advance.
Over half, 17, were density indicators, 8 fell into complexity category, 3 were caliber indicators, 1 came under the twistedness category. They say 118 retinal vascular measurable indicators were included, 29 were significantly associated with first-time stroke risk after adjusting for traditional risk factors. So they isolated those 29. They make reference to they also weighed more, had higher blood pressure, lower levels of good cholesterol, all of which are known risk factors for stroke in the evaluation of stroke risk. And 45,000 participants were analyzed during an average monitoring period of 12.5 years. 749 participants had a stroke. So this is actually something that has already been in place. So it isn't something, the research is showing something new, tying it to AI and using a system.
And comparing it to other methods, yeah.
Yeah. So what I was told, and it was rather recent when I was told it, so it's already deployed. So if you think that you might be susceptible to stroke or not, you should get your eyes checked once a year. At worst, like go and get checked once, and they will give you guidance about having to get checked again earlier or whatever. Oddly enough, it's the same thing like a colonoscopy. They check you once and go, we left our watch in there. Why don't you come back in a couple of months?
Do they appreciate jokes like that?
Well, when I cracked it, they chuckled, but I think they're not amused anymore. They're like, you know what? Anyway, let's keep moving. The next article is over in Technology Today. New technology uncovers DNA secrets behind disease and evolution. New research adds to our understanding of the function of the human genome. An international team of researchers has made significant progress in understanding how gene expression is regulated across the human genome. So I'm kind of fascinated by this. Genetics are really interesting, and I don't think that we really have a firm understanding of it. We know certain things and we take advantage of it, but Institute for Advanced Study of Human Biology, or ASHBI, I guess, Kyoto University, put the article together. It's over at scitechdaily.com. The human genome contains myriad of CREs, and mutations in these regions are thought to play a major role in human disease and evolution, explained Dr. Fumitaka Inui, one of the co-first authors of the study. However, it has been very difficult to comprehensively quantify their activity across the genome. So CREs are CIS regulatory elements, DNA sequences that control gene transcription. If there's a wobble, then you get disease, cancer, etc. So to address this, the team used cutting-edge technology called the lentivirus-based massively parallel reporter assay, or lenti-MPRA, which the authors had previously developed. This approach enables simultaneous analysis of thousands of CREs by tagging them with unique DNA barcodes that track their activity. We've actually talked to a knock-on experiment of this for things like DNA amplification.
Right, yes.
And other evaluative processes where they can basically detach a string of DNA and then inject a molecule that sits right into it. Yeah, it just sockets right in there, and then you know what this thing is.
It sounds similar to CRISPR, but it's a different method.
Different technology, yep. So applying lenti-MPRA, the researchers examined as many as 680,000 candidate CREs in 3 widely used cell types: hepatocytes, cells from the liver, lymphocytes, a type of white blood cell, and induced pluripotent stem cells, a type of artificial stem cell made from a normal body cell. Basically, pluripotent means that it can turn into any other tissue.
Oh, like it could become a liver cell or a
right with the
skin
right
cell or something.
With the right chemistry, yeah. So the study revealed several key insights. Across all 3 cell types, approximately 41.7% of the analyzed CREs exhibited activity. Promoters, which start gene transcription, showed a dependence on sequence orientation, but were less specific to cell types. And that's always the case. There's always sequence orientation when you're doing gene manipulation, there's always sequence. It goes 5-3-3-5. So enhancers, which boost gene transcription, and you can go in either direction depending on what you are doing. You just have to have the right chemistry in place. Enhancers, which boost, at least that's my understanding. So if you know more, correct me.
And we just talked about mirror.
Exactly.
Transcription, I think, was the term, but in a separate episode.
So these findings highlight fundamental differences in how these two types of CREs function. So enhancers and promoters. Enhancers boost gene transcription were active regardless. Sorry, I just got an alert. Were active regardless of their orientation and exhibited cell type specificity. So they're going to activate somewhere, but it's going to be a specific cell. So in the study, several machine learning models were developed to predict the regulatory activity of CRE based on large-scale experimental data. MPRA LegNet, a model trained on the vast Lenti MPRA dataset, also was found to be used and most accurate and efficient in predicting the regulatory activity of any DNA sequence. So its predictions align closely with experimental results, performing as well as experimental replicates in some cases. So basically, they're utilizing the machine learning so that they can predict what CRE activity will be. Kind of find it fascinating, right? So by enabling the precise identification and quantification of enhancer activity, the study opens up avenues for exploring the molecular mechanisms of human diseases. Future research will focus on applying this approach to study genomic polymorphisms, the variations of DNA sequence that contribute to individual differences and disease susceptibility. Because you can be twins, but there is enough genome differentiation and genetic polymorphisms that a person, the literal identical genetic makeup, but the expressions are slightly different, and one can fall prey to a disease and the other immune to it. Genetics, there's a lot of junk genetics data that we just don't know
what it is, right? And I think if they can better predict, then maybe they'll be able to determine that somebody is likely to develop a disease, but also that'll help in developing cures or treatments.
Yep. And the more data that they get, the more genetic data that they get, it turns into more actionable data for various experiments, and then it turns into treatments, general awareness. That phrase that we stand on the shoulders of giants is we benefit from the research done, and willful ignorance is going to lead to our destruction. So we really do need more money and more people in higher education doing fundamental research and then converting it into something that benefits all of mankind. Let's keep on going, though. This next article is our last one for Technology Today, turning plastic waste into sustainable jet fuel, which I don't know how it can be sustainable, but let's roll with this.
Well, right. I mean, maybe it is in terms of we're not creating more substances or something.
Something on the side as well.
Or pulling waste out of something else.
So researchers have developed a groundbreaking method to produce ethylbenzene, a crucial additive for sustainable aviation fuels from waste polystyrene. This is that white stuff that pads things that are being shipped.
Yeah, isn't this like packaging? So basically, packaging material is now going to be fueling jets.
Yeah, and just so when I was a kid,
directly and just load pieces of packaging in to the fuel tank. No, don't do that, anybody.
Kind of like Mr. Fusion from Back to the Future. This innovation could dramatically reduce the aviation industry's carbon footprint and reliance on fossil fuels, promising a cleaner, greener future in air travel with substantial cost savings and a 50 to 60% reduction in carbon emissions. But I don't see how this is actually possible. You're literally using a petroleum product and then converting it into fuel. I used to take gasoline and polystyrene and turn it into a thing called napalm, which was basically a gooey, very flammable material. And it was fun to play with when I was a kid. Do not do that, okay? It's very, very dangerous stuff. But anybody growing up basically has learned about this stuff. But University of Illinois at Urbana-Champaign put the article, would put this article together. It's over at SciTech Daily. Yeah, don't be a numbskull. I'm just talking. This isn't a show for kids anyway. But anyway, just don't be a numbskull. They say here, the new study addresses a major obstacle in transitioning U.S. commercial aircraft from heavy reliance on fossil fuels to sustainable aviation fuels. Researchers have developed a cost-effective method to produce ethyl benzene, an additive that enhances the performance of sustainable aviation fuel. So it enhances it using polystyrene, a durable plastic commonly found in consumer products. So while ethyl benzene is an aromatic hydrocarbon and can be derived from fossil fuels, finding a sustainable way to produce it would aid in the aviation industry's conversion to sustainable jet fuels. So they're going to use this plastic and derive this additive from it, ethyl benzene, and then put it into non-fossil fuels that would be used in jets to probably raise the octane so that it would actually fire.
I see. And maybe since we've already developed it, at least we're repurposing it.
Yeah, so let's see what they actually end up saying here. Goals for the sustainable aviation, advancements in ethyl benzene production. They don't really get too far into what it is that they're doing here, but they're saying that while this rule increases the safety and efficacy of the overall fuel mix, it severely limits the use of sustainable fuels, which currently contain only 0.5% aromatic hydrocarbons. But this polystyrene derivative is a hydrocarbon that would raise that level up so that they can actually use it in jet fuel. Currently, they use a blend of 20 to 30% sustainable aviation fuels and 70 to 80% conventional jet fuel. And it's that octane level, so it has to be like above 100 or something like that. I can't remember what it actually is, but vehicle fuel doesn't fire in jets. It has to have a higher octane level.
Right, which is probably good.
I think it's called like Jet A or something like that is the name for the fuel. So to convert a polystyrene to ethyl benzene, the team used thermal pyrolysis. They heated that shit up, heating it to break down the polymer into a styrene-rich liquid. A second step, hydrogenation, converted it into a crude ethyl benzene, and then distillation yielded a product that was 90% pure. So
they didn't just put pieces of packaging.
No, sorry, there no Mr. Fusion for you. What's interesting about this is, and I don't know if this comes as a surprise to people, but this is the same thing that produces fuel, right? All of this is oil. So oil is actually distilled and it turns it into various grades from gasoline to other things that get used up in various other processes, including orange 1, which is no longer allowed to be made. Red number 3, which was just banned. Red 40 is on the horizon to being banned. And many other fuel-based or oil-based products all come from what amounts to distillation. And all they're doing is distilling the same byproduct from oil. So they're using it up. But if you know, what comes out of distillation is a pure product, but what's sitting in the still is a nightmare. And that sludge has to be scooped up and thrown somewhere into a Superfund site that you find out about later when you cast your line out off the coast of California and you find DDT barrels still sitting down there, killing off all of the ocean life, which was just recently found like a year and a half ago, I think it was, when we first started the show. One of the articles that we talked about was that they found DDT barrels still killing stuff off the coast of Oregon. But because it is using something that's already been in place, they're saying that it's lowering the carbon footprint, but it's actually just shifting the carbon footprint from material waste.
Well, I think it's lowering the carbon footprint because then it's allowing the sustainable fuel to be utilized, and I think that's where the carbon savings are.
Sure.
Because without this addition or similar ones, the sustainable fuel wouldn't meet the requirements to be used. Yeah, sure. I botched that.
No, I get it. It raised the level so that it could actually be combusted in jet engines. But again, the distilled product is clean. The byproduct is a toxic nightmare unless they're doing something else with it. Nobody is taking a chug of that, Anyway, found it
we don't know. I mean, that's not covered in the article, but it's something that they need to factor in before this is adopted.
They say that it's cheaper than produced from crude oil, but only because of the back channel costs that are associated with getting crude oil. It's definitely cheaper to get crude oil than it is to go and get all of that material. Basically, all of the costs that are associated with this waste polystyrene has the entirety of the carbon chain behind it from oil all the way
factored in, right? It's only from we have polystyrene. Correct. Now we're starting on the costs.
Correct. Yep. And it says, and life cycle analysis of our ethyl benzene found it reduced carbon emissions by 50 to 60% compared with ethyl benzene made from crude oil, probably because they were actually looking at the entire life cycle of the ethyl benzene from crude oil and not the entire life cycle of polystyrene through the life cycle of crude oil through to benzene to polystyrene to ethyl benzene. It's a much longer chain because it's been in the environment for so long. Yeah, I think there's some disingenuous evaluation here, but I haven't read the actual paper. I would have to read the paper and actually see what all they took into account. And you can actually go and check it out too. There is a reference that's linked in this article: production of a sustainable aviation fuel additive from waste polystyrene. And it's over in ACS, Sustainable Chemistry and Engineering. Be sure to look into, when you look at this, and if you do this kind of stuff, go and look at this article, the journal entry, read the material, and look at the funding source. Anyway, it's one of the things that I look at when I'm reading a research paper. But that's it, folks.
I mean, it's important to know where it's coming from.
We're going to distill ourselves back to the front page of ohmTown's Technology Today channel at ohmtown.com. And then we're going to reset and do FourWheelTech and then call it a night. So thank you very much for coming and hanging out. I'm Mayor Watt saying bye, and so will the sentient AI.
Thanks for joining us for Technology Today. Stay tuned. We have another episode.
See you soon, everybody.